In today's lesson, we are going to be looking at the tangent ratio. So this is going to be our first lesson into trigonometry, and this is going to be one of the three kind of primary trig ratios that we're going to look at. And you might find that the next couple lessons are all going to be very similar, and that's on purpose because it's to show how the process or the kind of the calculations that we do with these ratios are all pretty much identical except for the ratio that we're using. So the process is going to be pretty much identical for everything, just changing out the ratio for a different one. So it also does show how it is very important to make sure that we understand this process because we do see the same process come up again and again. So first with trigonometry, trigonometry is the study of relationships between sides and angles in triangles. Right, so basically, these trig ratios, they basically, when we have different ratios of sides, we are given that will equal a specific angle, or a certain ratio will equal a specific angle. Now, this is all going to be done by looking at a right angle triangle. Right, so all of these three ratios that we're going to be dealing with are going to be dealing with right angle triangles, and there are three that we're going to look at: the sine ratio, cosine, and tangent. We're going to focus on the tangent ratio in this lesson. So in order to use right angle trigonometry, we need to label the three sides of a triangle. Right? And the three sides that we're going to be referring to are the hypotenuse, the adjacent, and the opposite. So if I have my right angle triangle here, I'm going to draw in my right angle just to make sure I have that and know where it is. And that is going to be important because it will help me label some of my other sides. So the side that is always across from my right angle is called our hypotenuse. And again, that is something that we might already know from looking at sum of squares or Pythagorean theorem. Right? The longest side in a triangle is our hypotenuse. Now this triangle might be rotated or orientated in a different way. So it might not be as straightforward as looking for the longest side. That's why it does help that it's always across from 90 degrees. Now our other two sides, the adjacent and the opposite, these two are based on what we call a reference angle. Now, our reference angle can be either an angle that we're given or an angle that we're trying to find. So for our purposes, I'm going to put a little symbol here. This little symbol is theta, which just refers to an unknown angle. We're going to call it our reference angle, though. So we're going to use this angle as a reference to help us label the other sides. Now, if this reference angle was actually up here instead, then these would change, or these other two sides would change. So if we think about opposite and adjacent, it's kind of, it does relate to what we actually call it. The opposite side, or the side that is opposite of our reference angle, is called the opposite. The side that is beside our reference angle, or is called our adjacent. So it's even in the name where it should be located. Adjacent is beside, opposite is across. Right, so we do kind of see that again with how we label them based on the reference angles. But again, the opposite and adjacent could switch depending on which reference angle we're using. And that would be clear in our questions. So with our tan ratio, we are dealing with tan theta is equal to opposite over adjacent. So our tangent ratio is a specific ratio. We have theta again, this is an angle, and it's opposite over adjacent, and these two represent side lengths. So we have an angle in our equation and two side lengths in our equation. it's basically saying whatever the ratio of these two side lengths are, it will give us our angle, or that tan ratio will give us our angle. So let's go through some examples of trying to find a side length. So we have x angle of 71 up here and 18. Now, yes, I know we're dealing with the tan ratio, but it doesn't hurt to get in the habit of always labeling our sides. Right? So we have our right angle, so the side across is our hypotenuse. We have our reference angle, this is the one that's given to us. So 18 is our opposite. And x is beside, so this is our adjacent. Now we are dealing with the opposite and adjacent, and we know this is our lesson on tan. So we're going to write our formula, tan theta equals opposite over adjacent, or you could just say O over A. I'm going to plug in my values. So tan theta, or tan of 71, is equal to opposite 18 over x, our adjacent. Now, if I wanted to go through and solve this, I can do so now. I can solve this equation for x. And what we're going to do is we're going to bring the x up to the other side. We don't want it in the fraction anymore. We want it up on top. So it's going to be x times tan of 71. And now when you do tan of a value, tan of a number, it's going to give you just another number. Right? It's going to give you the ratio for that specific angle. So the ratio for when the angle is 71 degrees. So we can move tan of 71 as if it was just an actual number. So if I still want to get x by itself, that means this tan 71 has to come over or move over to the other side. And because we're multiplying on one side, it becomes division on the other. So I get x is equal to 18 divided by tan 71. And now this is a calculation because I can calculate what tan of 71 is. So 18 over, and then tan of 71 is 2.9. We'll just say 2.9 rounded. So now I can go through 18 divided by tan 71 and get x is equal to round 6.2. So that means that unknown side is 6.2. Now, one thing to note, if you didn't get that value, but you're confident you plugged everything in, make sure your calculator is in degree mode. Your calculator needs to be in degree mode when you're doing this. Basically, it's saying we're going to look at angles and refer to them as with the units of degrees. So make sure you're in degree mode. Now, what you're looking for is you're looking for something that says D or maybe DEG on your calculator. So somewhere on the home screen, somewhere on the screen, usually up at the very top, kind of like a little banner, you might see something that says this. If you see something else, and a common one would be R or RAD, R-A-D, right? So you might see something like this, R or RAD. That we don't want. We don't want to see those. So if you do see D or DEG, then you're good. It might just be a calculation error on your part. If you see R or RAD, then the chances are your calculator is just in the wrong mode and you need to change it to degree mode. So if you're practicing this at home and you're unsure, just let me know and I can work with you to kind of make sure you're in the right mode on your calculator. Because I don't want you getting marks wrong because you just have a calculation error or a calculator error. So that was A. Let's look at B. We're going to go through the same thing. We're going to label our sides and go through the whole process again. So we have our 90-degree angle. So we have our hypotenuse. We have our reference angle of 64. So across is our opposite. Beside is our adjacent. Oops. I am going to use my tan ratio, and again, we'll have a lesson later where we look at how to identify which ratio to use. But again, we should have the opposite and adjacent in some form. So our opposite, oops. So tan theta, our formula says opposite over adjacent. I'm going to plug in my values. So tan of 64 is equal to x over 11. Now in this case, a little bit of less work because I can just bring the 11 up and multiply. So I have 11 times tan 64 is equal to x, right? Because our whole goal is to solve for x. And we get 22.55 equals, or we'll say 22.6 equals x. So that means that missing side length is 22.6. Now we're going to go through two more examples. There's a similar idea of finding side lengths, but at the end we're going to look to see if there's an easier way or kind of like a pattern to kind of look for. We're going to see it's a very similar setup. So again, we're going to label our sides. Across from the right angle is our hypotenuse. Our reference angle is 28. Across from that is our opposite. Beside that is our adjacent. So I would say always start with that. Find your hypotenuse, then find your opposite, and then the last side will be your adjacent. So again, we're dealing with tan. So opposite over adjacent. Tan of my angle of 28 is equal to 12 over x. Now I could move the x up and then I have to move the tan 28 down or divide by tan 28. So a quicker way might just be to recognize, okay, if I'm going to move the x up and then the tan 28 down, why don't I just say at the beginning, I'm going to switch them. I'm going to switch the tan 28 and the x. And now I'm going to go through and calculate. So 12 divided by tan 28. And if you're comfortable with this, you can do this all on your calculator at once. 22.6. So that is our unknown side, 22.6. So now we've done two questions where the missing piece is on the bottom. A at the beginning and C that we just did. So what's a tip that we could do when the missing piece is on the bottom? Well, in this case, if the missing piece is on the bottom, we can switch and divide. Right now, there's a little bit more to that. It's not like there's more to like specifically what are we switching, but it's just kind of a little bit of a reminder. Okay, if the missing piece is on the bottom, I should be switching and dividing, and then that it's up to us to know what we're switching, so that we know that we're dividing the correct things. If I look at D, right, same idea. Let's go through and try to solve for this angle or this missing side. I have my reference angle. So I'm going to label my sides. I have my hypotenuse across from 90. I have my opposite, which is across from my angle. And I have my adjacent, which is the last side. We are dealing with tan. It's going to be opposite over adjacent. So tan of my angle, tan of 57, is equal to opposite, which is x, and our adjacent, which is 19. Similar to our last one, we said, okay, if I want to get x by itself, I'm going to bring 19 up and multiply it. So I get 19 times tan 57. Which is equal to x. And now I just have to multiply. This is, again, can be one calculation. 29.3 is equal to x. So again, a shortcut for this one, we've now done two questions where the missing piece is on the top. And what did we do to solve? Well, it looks like we just brought the bottom number up or the denominator up and we multiplied. We brought the denominator up and we multiplied. So when the missing piece is on top, we could just say bring up and multiply. Again, there's a little bit more to it, but at least if we start remembering, okay, I bring up and I multiply when the missing piece is on the top, it just kind of helps with that process. The last thing we're going to look at is finding angles. And now when we're finding angles, we have to use the inverse of our trig function. So on your calculator, this is going to look like pressing the second button or the shift button and then tan, and you're going to look for, on your calculator, it appearing to be tan -1, or the inverse. It's not tan to the power of -1, it's tan -1. So again, look on your calculator, you should see it above the tan button. You should see a small, in small writing, tan -1, probably maybe in a different color, but something indicating that you have to hit shift and then that button. Again, it varies from calculator to calculator, so make sure you are aware of where that button is. So let's just kind of go through and calculate the angles using the inverse. And how that looks, if I know that tan of theta is equal to a value, and I want to find theta, I want to find this angle. What I have to do is I have to move tan. I have to get rid of tan. And the operation that tan, you could think of tan as just being an operation. So the opposite of tan is the inverse. So if I move tan to the other side to get theta by itself, it becomes tan -1 of whatever is on the other side of the equal sign. So tan -1, or the inverse of tan, 1.56. Again, making sure we know how to use our calculator. That's all we're doing. We're just calculating it. We get an angle of 57.3 degrees. So that means if your two sides have a ratio of 1.56, the angle should be 57.3. Look at the next one. Similar idea. We're just making sure we can use our calculators. So the inverse of tan of 2.5. And get 68.2 degrees. Lastly, even if we had a fraction, we can still go through and do this, and this is what we're going to be doing in a few seconds. Right? But again, if I want to find my angle, I'm going to move tan to the other side. 6 divided by 19. If we really wanted to, we could figure out what 6 divided by 19 is first. Or if you're more comfortable with it, you can enter this all into your calculator. Tan, the inverse of tan, and then brackets 6 divided by 19 to get our value. And we should have an angle of 17.5 degrees. So again, this was all just more or less just making sure we can use our calculator, make sure we're getting the correct numbers so that we know that it's in the right form or mode. Now, how do we do this looking at a triangle? Well, again, we're going to start with labeling our sides. We have our hypotenuse. We have our reference angle. Even though we don't know what the angle is, what the measure is, it's still going to be our reference because that's what we're trying to find. So across from our reference angle is our opposite. Then beside it is our adjacent. I'm going to write out my tan formula or my tan ratio. Opposite over adjacent. I don't know what tan is or what theta is, so I'm going to leave that, but opposite is 21 over adjacent, which is 20. Well, now I have something very similar to what we just looked at. So if I want to find theta, I'm going to have to move tan to the other side, where it becomes the inverse of whatever was over there. So tan, or the inverse of tan of 21 over 20. And we should get an angle of 46.4 degrees. So that means based on those side measurements, that angle is going to be 46.4 degrees. Last example, again, similar idea, label our sides. Hypotenuse, we have our opposite of our reference angle. We have beside our reference angle. We're only using tan in this lesson. So tan theta equals opposite over adjacent. Tan of an unknown angle is equal to 3 over 4. If I want to get theta by itself, again, I'm going to move the tan over. Comes the opposite, which is tan, or the inverse of tan of 3 over 4, 0.75. Again, if you want to convert that to a decimal and just do tan negative 1, or the inverse of tan of that, that is fine. But it is helpful if we leave it as a fraction and just divide in there, because that will make sure that all of our decimal places are included. And we should have 36.9 degrees. So there's no other method to, or not, I don't want to say there's no other method to finding an angle, but when we're finding an angle using our trig ratios, it's always going to be this same process. We're going to have two values that make up our fraction, or fill in a numerator and a denominator, and then we just have to do the inverse of our trig function, or trig ratio. In this case, tan. So like I've mentioned before with some of these concepts, because this is something new, please make sure you are practicing it. It really helps when you do practice the concepts over and over again, not just when you get it, or if you get it right away. You should still be practicing consistently to make sure, that you do remember it and it wasn't just a one-off.